You ask your AI coding agent to build a feature, and seconds later, you're staring at an overwhelming, overflowing wall of unstructured, broken code. This happens because standard AI coding models operate purely on impulse. They lack methodological structure, generating text based on statistical patterns rather than engineering principles, which ultimately forces you to spend hours debugging their mistakes. The obra/superpowers repository solves this. It acts as a strict framework that forces discipline onto the AI, interrupting its impulses and making it adhere to a rigid set of rules. This bar chart shows the scale of adoption for the Superpowers Framework compared to standard developer tools. Earning 169,000 stars and 15,000 forks on GitHub, the repo has become a primary resource for developers looking to rein in chaotic agents. The framework functions as a digital straitjacket, translating software best practices into automatic constraints that force a chaotic junior AI to work with the precision of a senior engineer. A normal AI begins spitting out lines of code the exact millisecond you hit enter on your prompt. A superpowered AI does the exact opposite. The framework forces the agent to hit the brakes before a single line of logic is written, automatically triggering specific brainstorming protocols. During this mandatory planning phase, the agent must ask clarifying questions about your goals and formulate a comprehensive design document for your approval. Once you approve the design, the framework forces the AI to break the entire project down into bite-sized execution tasks, each designed to take no more than 2 to 5 minutes to complete. By forcing the AI to plan and scope its work in small increments, you prevent it from sprinting down irreversible, hallucinated rabbit holes. You save countless wasted generation cycles because the AI actually knows where it is going. Standard AI assumes the code it just generated is completely flawless and immediately moves on to the next task without verifying anything. This circular flowchart maps out the central constraint of the Superpowers Framework. It strictly enforces a test-driven development, or TDD, cycle for every single task. In the first step of this rule, the red phase, the AI is strictly required to write a failing test case before it is permitted to write any functional code at all. Only after watching that specific test fail is the AI allowed to enter the green phase, where it writes the minimal amount of code required to make the test pass, before looping into a refactor phase to clean up the logic. Enforcing tests prior to logic mathematically prevents the AI from producing unverified spaghetti code. This grounds the AI's output in verification and proof, rather than just predictive text generation. Working with a standard AI is a solo workflow. The agent acts entirely without oversight, trusting its own output without any secondary validation. To fix this, the framework relies on sub-agent-driven development. It forces the AI to subject its own work to peer review. This architecture diagram visualizes the first stage of that review. The primary agent dispatches a fresh, independent subagent to inspect the completed code strictly for compliance with the original approved specifications. Once the specs are verified, another independent subagent is dispatched to review the exact same code, this time focusing exclusively on code quality, formatting, and potential edge cases. This multi-agent cross-examination mimics the rigorous code review process of a real-world engineering team. By utilizing separate agents for separate checks, the framework eliminates the blind spots inherent in single prompt generation. Everything in the Superpowers repository is built on 2 core philosophies: prioritize systematic processes over ad hoc guessing, and always demand evidence over claims. To get highly reliable code, you don't necessarily need more raw intelligence or a larger model. You need to provide your current AI with adult supervision and strict boundaries. The success of this approach suggests that reliability in AI-driven development relies less on the scale of the model and more on rigorous engineering methodologies. If this breakdown saved you time and helped you build better systems, hit subscribe. We review and dissect engineering tools like this every single week. To see how to run these disciplined agents entirely offline, click the video on screen right now for our breakdown of open-source local coding environments.